Alright, so let's go ahead, let's put it all together. We've been talking about reactions. We know we've got to conserve our matter. We've got to have the same number of atoms before as we do after. We know that we've got to have balanced equations, and the fulcrum point is that arrow right there in the middle. We know our state symbols: liquids, solids, gases, precipitates, aqueous solutions. We've got it all. Let's go ahead, put it all together. We also now know how to name our different compounds. So if we came across a problem where we had to write a balanced equation, we would start by figuring out our reactants and our products. Start by writing the formulas first. Determine those charges. Make sure you watch for those ions. Write your viable compounds first. Remember, atoms want to be stable. Do that first. Remember to watch out for your diatomic elements. Hofbrinkel. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine never come alone. They always come in buddies. Always come together. Always got a wingman hanging out there with them. So write those stable compounds first. Then put them together. Put your reactants together, put your products together, put in your little arrows, put in your state symbols to tell you what state those different substances are. Put all the reaction pieces together. Reaction assemble. And then the last thing we ever do when we're writing balanced equations is to balance using our coefficients. Use your coefficients then to make it so that both sides of that fulcrum have the same number of atoms. Cool. Now that we've got those pieces, let's go ahead and try one, eh? Yeah? Yeah, okay. So let's practice writing some equations. So propane. Propane gas burns in oxygen to produce carbon dioxide and water vapor. All right. All the pieces are there. All we got to do is pull them out. Let's start by finding our substances, our chemicals. We've got propane. Ane tells us the hydrocarbon. We've got propane gas burning with oxygen to make carbon dioxide and water vapor. What does that produce mean? Produce. To produce. Produce means products. There's our reaction. There is our arrow. All right, so let's start. Step one, write your viable compounds. Propane. Me eat peanut. CH, peanut for 3. To find your number of hydrogens, take the number of carbon times 2 plus 2. So 3 times 2 is 6, plus 2 is 8. Burns in the presence of oxygen. Hofbrinkel, watch out for those guys. Oxygen never comes alone. It's always O2. And produces carbon dioxide. Oh, that's a nice one. Carbon dioxide. And water vapor, which would be our H2O. So we start by writing all of our viable compounds. Now we go back and we assemble the reaction using our state symbols. Well, we know the reaction is that produces, which means that these two are going to react together to make these two guys. We've got propane gas. State symbol for gas is G. Go ahead and slip that guy in there. Burns in oxygen gas. There's another G. To make carbon dioxide gas, cool, another G. And water vapor. Vapor as in a gas, as in steam, gets a G as well. All right, the very last thing, we got step one, write your viable compound. Step two, put in your state symbols, assemble the reaction. Step three being balance. So let's go ahead and let's balance this. Let me change up colors one more time for us so we know what step we're on. Step 3, sure, red, why not? Nice color. All right, pick an element. Doesn't matter which one. We've got 3 carbons on the left-hand side. We need to have 3 carbons on the product side. So can't we just put a 3 in here? That'll balance it, right? We're good to go. 3 on the reactant side, 3 on the product side. What's wrong? What's wrong? Why, some of you, I hope, are screaming at your screens. C3. You can't change. We just changed the compound. Went from CO2, carbon dioxide, to like tricarbon dioxide. We don't even know if that's stable. You can't do that. Make them stable. When you go to balance, then we get our coefficients. You can't just change up the compound. Can't do it. Can't do it. Got to use coefficients. So we got 3 carbons on the reactant side. We need to have 3 on the product side. Let's leave the oxygen till the end here, just because it's gonna be easiest by itself. Just change that, and change anything else. So we'll leave that guy till the very, very end. All right, we got 8 hydrogen on the reactant side. We got 2 on the product side. We need to multiply that guy by 4. All right, we've got 2 oxygens on the reactant side. We've got 3 times 2, 6 oxygens in that carbon dioxide, plus 4 more gives us a total on the product side of 10. All right, 6 plus 4 is 10 on the product side. We'll need to multiply this guy by 5 to get it to balance out. All right. We can do this. Nomenclature, nothing new there. State symbols, kind of new, but okay. If it's gaseous, gets an G. If it's solid, gets an S. If it's precipitate, gets an S. If it's aqueous solution, gets an AQ. Or if it's in solution or an acid, gets an AQ. If it's a gas, G. All right, we got this. All right. Balancing, continuing to practice this idea of balancing, but once we got that, we are good to go. Good. All right, so now we've practiced some together. You go ahead and give some a shot for me. We're going to make sure we're all ready to go as we move ahead. Best of luck.